Okay, we'll take a look at our Chapter 8 review here. And this review, we'll look at starting off with solving some oblique triangles. We've got a triangle here in number 1 that we need to solve. It says round your answers to the nearest hundredth. We've got two angles and a side given. Angles B, 52.8 degrees, angle C, 114.6 degrees, and side B, which is side opposite angle B, which is 10.13 units in length. First thing we want to do, of course, is to get a sketch, get a picture. So let's go ahead and look at this triangle. So we've got an obtuse angle of 114.6 degrees. So we'll go ahead and draw in that obtuse angle here. We'll let this be angle C. We'll let this be A, and we'll let this be B. So again, angle C is given to us. This is a 114.6 degree angle. And angle B is given as 52.8 degrees. And side B, the side opposite angle B, is 10.13 units. All right, what we don't know, right, is angles A. All right, we've got to find angle A. We've got to find side C and side A. So we've got 6 parts to a triangle. Half of it is given, right? We're missing the other half, right? So again, that's what we're looking for in this problem, is we got to find that information. We need to find out what angle A equals, right? And we need to find out what side A equals and side C equals. Now, in this triangle, let's talk about what type of oblique triangles. Again, oblique, a triangle without a 90-degree angle in it. We've got 2 angles and a side given, right? Angle, angle, side opposite. So in a angle, side triangle, right, we can use the law of sines to solve, right? And the law of sines states sides are proportional to the sines of the opposite angles. So A over sine of angle A equal B over sine of angle B equals C over sine of angle C. Right? So that's our law of sines. So again, these ratios, we can set up these proportions. Sides are proportional to the sines of the opposite angles. So we'll use that to help us get to our information here. Now we know from the get-go, let's go work on finding angle A. We know 2 of the 3 angles, so we can use some geometry. So we know angle A, right? We know all 3 angles in a triangle add up to 180 degrees. So angle A is going to equal 180 minus 114.6 degrees plus 52.8 degrees. All right, so again, we can plug in our calculator if we need to, do the arithmetic. We'll do it together here. As we add these two together, we get 167.4 degrees. All right, and then as we subtract, we get 12.6 degrees. So here's angle A. So angle A is 12.6 degrees. So we got 1/3 of our solution. So we found A. Right, if we need to, we could label that. Now let's go ahead and find side A. So as we move on to side A, well, let's use our law of sines. So let's take our law of sines. We know that A over the sine of angle A, right? And that is what? Angle A is 12.6 degrees, which we just found, equals, let's use B over sine of angle B. So B is 10.13 units over the sine of angle B, which is 52.8 degrees. All right, so we set up proportions. So A over sine of angle A equal B over sine of angle B. And as we solve that, let's go ahead and solve this for A. Let's go ahead and get A by itself. So I'm going to go ahead and multiply both sides by the sine of 12.6 degrees. All right. So we can get A isolated. So as we do that, we have A equal to 10.13 times the sine of 12.6 degrees divided by the sine of 52.8 degrees. All right, and now we can put that in our calculator, right, and come up with our answer. So let's go ahead and do that. We'll pull up our TI. Let's go put up our calculator together. Now on a calculator, right now my mode is in radians. So on my TI, I'm going to change it over to degree mode. And let's type that in. So we got 10.13 times the sine of 12.6 degrees, all right, divided by the sine of 52.8 degrees. So I end up with 2.77, right? Once we round to the nearest hundredth, we get 2.77 units. So here's side A, right? So we just found side A. And now we're ready to go find our last part, right, which is B. So the only thing left to get is side B. So let's go ahead and get B. Now to find B, let's set up our ratio. So B over the sine of angle B. And I'm sorry, we already have B, right? We don't need B. We already know B is 10.13. Right, what are we looking for now? We're looking for side C, right? That's our last piece of information. And let's use a ratio. So C over the sine of angle C. So C over the sine of 114.6 degrees equal to, I'm going to stick to, I could use A over sine of angle A since I found side A. I always like to stick to the given information as long as I can because I know that's correct. So B over sine of angle B, 10.13 divided by the sine of 52.8 degrees. So I'm going to use that ratio. And let's go solve it. So we're solving that, right? We can go ahead and multiply both sides by the sine of 14.6 degrees, right, to clear that out. And as we do that, we get C equal to 10.13 times the sine of 14.6 degrees divided by the sine of 52.8 degrees. And again, we go type that in our calculator. So you can put that in your calculator. I'll let you type that one in. You get 11.56 if you round to the nearest hundredth. So again, you can go ahead and type that one in also on your TI. And there it is. We've solved it. So we found our three parts, right? Our three missing parts. Angle A, right? Side C, and side A. So we've got all 6 parts to this triangle here, this oblique triangle. So like I said, we can label that in there. All right, so again, that's solving an oblique triangle. Let's move on. Let's go to our next example, problem 2. And problem 2 wants us to find the area of the given triangle. And they give us half the triangle. They give us an angle and 2 sides. So angle C, side B, and side A. Round your answers to the nearest tenth. So let's go get a picture of this triangle. So we've got, draw it in. We'll draw in this triangle ABC. So standard lettering, capital angles, or capital letters represent the angles. 48.3 degrees for angle C. We'll let this be A. I'll let this be angle B. And side opposite of B is 85 feet in length. Go ahead and label that. Side opposite angle A is 12.7 feet. All right, well, how do we find the area of a triangle? So let's review area. So area is equal to 1/2 times base, right, times height. So we're going back to geometry. Well, we've got our base. So here's our base in this triangle, right? Now we got to find the height. So let's go ahead and draw in the height. So how are we going to find the height? We're going to drop the perpendicular, right, from the top down to the bottom here in the base. And when I do that, I form a 90-degree angle, right? That's perpendicular, right, to the base. And, of course, that's how tall or how high that triangle, that's the height of that triangle. So we need to find the height. So H is equal to the height. Well, let's go find H. Well, what will allow us to find h? Well, if we look, we formed a right triangle here. So let's use our right triangle trig. So we can use angle C. So if I ask you what's the sine of 48.3 degrees, it would be equal to h divided by 85, because sine is opposite, right, over hypotenuse in a right triangle. So I use my angle here, angle C, to find height, right, using the sine definition. I had to find the opposite side of 48.3 degrees, so I needed sine definition. So as we solve that, so again, using some right triangle trig, right, I'm going to go ahead and solve that for h. Let's go ahead and multiply both sides by 85. And as we do that, right, we come up with h, right, equal to 85 times the sine of 48.3 degrees. So there's the height. So we got our height now. So we have the base and we have the height. So let's go back to our area definition. Area is 1/2 times base, which we know is 12.7 feet, right? And then the height, which we just calculated, is 85 times the sine of 48.3. All right, so let's go plug that in. So what is that? What do we come up with? All right, let's go see what our area is. We'll put it here in our calculator. Clear out the last problem. So 1/2, I'll put in 0.5, times 12.7 times the sine of 48.3. All right, and we come up with what? As we typing that in. Now we got to type that in correctly. What was it? 0.5 times 12.7. The height, the base was the 12.7. The height was 85, right, times the sine of 48.3. So make sure we type that in correctly. And now get 402.99. All right, well, let's go ahead and round that. So that's what? 403. Right? 403 square feet squared. All right, so we found area, right? Finding the area of that triangle, right, in that problem. So let's go ahead and continue on. All right, and we'll look at problem number 3. And number 3, we want to solve another triangle. We'll solve this oblique triangle. So solve the triangle if possible, round to the nearest hundredth. All right, so let's go take a look at triangle ABC here. So with triangle ABC, we'll go ahead and label these sides here. Let's go ahead and get a quick picture of what this triangle looks like. All right, so we got angle A, we got angle B, we got angle C as we draw that in. Now, angle A, B, and C are unknowns, right? We don't know the angles. They didn't give us these measurements. Right? We got to find those angle measurements. What we do know are the lengths of the sides. So side A, well, side A we got 7.6 units in length. Side B is 13.7 units in length. And side C is 16.8 units in length. So there are 3 sides of this oblique triangle. So as we're looking at that, we see that we have what we call a side-side-side triangle. Well, in a side-side-side triangle, right, we're going to solve using the law of cosines. Right? And the law of cosines, what does it state? All right, you pick any side, side A, B, or C. The square of that side always equal the sum of the squares of the other 2 sides minus twice their product, 2BC, times the cosine of the angle opposite side A, which is side or angle A. So that's A squared. Or again, we could be looking at B squared equal to A squared plus C squared minus 2AC times the cosine of angle B, or C squared equal to A squared plus B squared minus 2AB times the cosine of angle C. So let's go find these sides. So let's start off with, all right, let's go find angle A. We got A, B, and C to go get. What does A equal? What does B equal? And what does C, angle C, equal? So in finding angle A, all right, we're going to need to use our law, right? A squared equal to B squared plus C squared minus 2BC times the cosine of angle A. So that implies, well, A, again, is 7.6 squared equal B squared, 13.7 squared, plus C squared, 16.8 squared, minus twice their product, 2 times 13.7 times 16.8 times the cosine of the unknown angle A. So what happens now? We got to solve this equation, right? We got to solve for A, right, the cosine A function. So we got to go ahead and subtract these terms over. Let's move these over. So what will that give us? As we subtract those over to the other side, that implies 7.6 squared minus 13.7 squared minus 16.8 squared equals negative 2 times 13.7 times 16.8 times the cosine of A. Now, our last step, right, we need to divide out these coefficients. So that would be our next step. We got to get rid of the coefficients. There'd be a multiply with it. So we would go ahead and divide that out on both sides. So again, doing our algebra, let's go ahead and see what we come up with as we divide out these coefficients. So as we do that, we finally have solved for A, the cosine A function. So that implies what? Cosine of A is equal to 7.6 squared minus 13.7 squared minus 16.8 squared divided by negative 2 times 13.7 times 16.8. Now that's cosine A. Now we need A. So how are we going to get A? We're going to use inverses. We need to swap these out. So cosine inverse of this fraction. So let's go ahead and type this fraction in. So cosine inverse is 7.6 squared minus 13.7 squared minus 16.8 squared divided by negative 2 times 13.7 times 16.8. All right, so let's go to our calculator and let's see what we come up with as we type that in. So let's put that on our TI. So we'll clear this one out. So again, we're already in the right mode, degree mode. We're going to hit the second cosine button. And we'll go ahead and put in this information. Now I need to start a parentheses for the numerator. That's 7.6 squared minus 13.7 squared. All right. Minus 16.8 squared. All right. Close out the numerator. Divided by denominator. Let's put in parentheses. Negative 2 times 13.7 times 16.8. So just be careful as you're typing that in. Make sure you got your parentheses where you need it. Then hit the enter button, and you'll get your angle measurement. So I'll get 26.44 around to the nearest hundredth. So at 26.44 degrees. So let's go ahead and put in our angle measurement. So rounding to the nearest hundredth. So to go to 2 decimal places. So there's angle A, right? We found 1/3 of our solution. And now we'll do the exact same thing to get angle B. So let's go ahead and show finding B here together. All right, so to find angle B, what are we going to use? We're going to use our law here. B squared equal A squared plus B squared, or A squared plus C squared minus 2AC times cosine of angle B. So let's go ahead and put that in. So B, which is 13.7 squared, equals A squared plus C squared, 7.6 squared, plus 16.8 squared, minus twice the product, 2 times 7.6 times 16.8 times the cosine of angle B, our unknown. So that's what we're solving for, B. So let's go ahead and do that. Let's go ahead and do our work, our algebra. We need to subtract these over, move them over, and then divide out our coefficients. So in the end, I'm going to skip the step here. We know cosine B is going to equal 13.7 squared minus 7.6 squared minus 16.8 squared. All right, divided by the coefficients, -2 times 7.6 times 16.8. All right, and then you're going to use your inverse feature. So B will equal cosine inverse of that fraction. So we swap it out. All right, and you can go plug that in your calculator. All right, and come up with your angle measurement for B. And as you do that, all right, I'm going to go ahead and let you type that in. Same thing we did the last one. All right, we come up with angle B to be 53.38 degrees. All right, so let's put that here underneath it. I don't even see it. 53.38 degrees. So again, go to your TI, right, and you can type that in there. So erase that. So there's angle B. So now let's go to our third and final angle. So now we're going to find angle C. Well, once we know A and B, we can find C. So we know C is equal to 180 degrees. We know all three add up to 180. Minus the sum of the two we have, 26.44 plus 53.38 degrees. And that's 180 minus 79.82. As you do the arithmetic, you get 100.18 degrees for angle C. So now we got all three angles, angle A, angle B, and angle C. So we've solved our oblique triangle, and we did it using the law of cosines.